Hello everyone, welcome to another video. So today we'll be discussing about differentiation. So first of all, let's start with an example here. So if we are having a function f of x, so when we are taking the derivative or when we are differentiating this function, we'll be using this. This is the main formula for differentiation, which is limit h tends to 0 f of x plus h minus f of x the whole divided by h. So to solve this one, let's take an example first. Now instead of f of x, if you are having the function as sine x, right? So how to solve this, how to find the derivative of this sine x using this formula. So let's see how to do it. First what we have to do means write the same thing, limit h tends to 0. Now instead of f of x plus h, what is our f here? It's sine x. But instead of h, we are x, we are having x plus h, right? So you should write it as sine of x plus h by minus, then f of x is sine x itself by h. So this is the main formula we will be using here, sine of x plus h. To divide this, it is having two angles added together, so we will be using this formula, sine of the first part times cos of the second one plus sine of the second one cos of the first one. So when you are expanding sine of x plus h, you can expand it like this. So writing the second part as same itself, sine x, then the whole thing divided by h. Now I have just rearranged the terms, sine x cos h and minus sine x. This one was here, so I changed its position to here now. Now if you check, these two terms are having sine x as common, so we can write it together, sine x. So what will be left out? It will be cos h here and minus 1 here. We took the sine outside, so only minus 1 is left. And we can also distribute the h which is down. See, h is a denominator for all the terms, right? So we can distribute it. It's not an issue. When we're taking the limits, we can distribute the limit also when we are having plus or minus sign. So the limit will be distributed to each of the terms. So the first one will be limit h tends to 0 sine x times cos h minus 1 by h plus sine h cos x by h. Here also there's a limit, h tends to 0. So we are having a formula here, limit of h tends to 0 sine x by x. If you are having the same sine of a variable and divided by a same variable, then when we take the limit of that variable tends to 0, we'll get the answer as 1. So if you check this part, right, it will actually yield us 1 as the result, and the other one will be left out, cos x. So this part will be writing now the same, limit h tends to 0 sine x cos h minus 1 by h. As we were continuing, we have to use one more formula here. We are having the formula limit x tends to 0 1 minus cos x by x, it's equal to 0. Or if you have the numerator in the opposite order also, it's not an issue, we'll get the same answer as 0. So if you check here, when we are applying the limit here limit h tends to 0, so the variable is h, and this part, if you check, it's similar to this one, right? Limit h tends to 0, instead of x we are having h, and here also cos x minus 1, cos h minus 1, and instead of x, h. So this part will be actually 0. So sin x multiplied with 0 plus cos x. So the final answer is cos x. So this part will be 0 itself, so only cos x is there. So when we are taking the differentiation of sin x, we are getting the final answer as cos x. So the differentiation of sin x is cos x. For differentiation, when the function is f of x, we can represent it in many different ways. We can write it as f dash of x. For the differentiation of f of x, we can write it as f dash of x, or dy by dx, or y dash, because usually we'll be representing f of x as y also. So it will be dy of d over dx or y dash. So these are the some of the representation for the differentiation.